244 hours. Over the occupied darkness of Zaporizhzhia Oblast, 3 Ukrainian strike drones slice through the night. Below them, a target of immense strategic value glides along the railway line. An 8-car train, a rolling pipeline hauling 560 tons of Russian fuel, enough to power 2 entire battalions for a week of combat. But the Russian crew, moving through the quiet countryside, has no idea. In less than 60 seconds, that fuel will not be powering tanks. It will be lighting up the Ukrainian sky. This is not a simple attack. It is a symphony of destruction conducted by a Five-Drone Orchestra. One DJI Mavic 3 reconnaissance drone serves as the eye in the sky, providing overwatch from 8 kilometers away. 3 Ukrainian-built FPV quadcopters are the tip of the spear, designed for one-way strike missions. A second Mavic hangs back, a silent reserve, ready in case the primary eye is blinded. These are not off-the-shelf consumer toys. They are battlefield-forged weapons. The Mavic 3 reconnaissance platforms are masterpieces of field modification. Their stock cameras, already powerful, are pushed to their limits with experimental firmware, extending their zoom into staggering detail. Crucially, many are retrofitted with advanced thermal cores. These cores can detect minute temperature differences, turning the cold night into a high-contrast map of enemy activity. Flying at nearly 70 kilometers per hour, they are the mission's persistent, all-seeing sentinels. In stark contrast, the FPV attack drones are built for a single, violent purpose. They are stripped-down, optimized killing machines. Using 7-inch propellers on powerful brushless motors, they are tuned for raw speed and terminal stability. In their final dive, they can exceed 140 kilometers per hour. They are designed to hit their target with absolute, unyielding precision, making them one of the most cost-effective strike weapons in modern warfare. 30 kilometers away, inside a secure command bunker, Ukrainian operators watch the world through the drone's eyes. On their thermal feeds, a distinctive heat signature materializes against the cool landscape. It's the locomotive's diesel engine, a bright white bloom against the black of night. Target identification is instantaneous, unquestionable. The lead reconnaissance operator confirms visual contact. The signal is encrypted, a ghost that Russian aeroscope systems designed to track standard DJI drones cannot see. The feed is patched in real time to the strike operators. 3 pilots, each behind an FPV controller, acknowledge the targeting data. Their moment is coming. Strapped to each of their one-way quadcopters is a 2.6 kilogram shaped charge warhead. These are not crude explosives. They are engineered to defeat armor. Each features a dual-stage detonation system. The first stage uses a hardened penetrator of tungsten alloy, designed to punch through the 12mm steel walls of a Russian fuel car as if it were paper. The second stage ignites the payload. The shaped charge focuses the explosive energy into a concentrated jet, a lance of molten metal and gas traveling at over 30,000 feet per second. It pierces the tank and, in a fraction of a second, ignites the contents with temperatures exceeding 2,500 degrees Celsius. It is a weapon designed to turn fuel into fire. But the most critical element of this strike package is not a piece of hardware. It is time. For 72 hours, Ukrainian intelligence tracked the specific train. A network of partisan spotters, ordinary civilians living under occupation, risked everything to provide the data. Using simple smartphones, they logged its schedule, its speed, and its route. They identified its most vulnerable moment, a crucial 15-minute window where it would be farthest from Russian air defense umbrellas. These shadow operatives, whose courage will never be publicly known, delivered the final piece of the puzzle. The target was confirmed electronically and visually. The kill box was set. The first strike operator pushes his controls forward. His FPV quadcopter peels away from its holding pattern, beginning a shallow dive toward the moving train. The drone's targeting system is a hybrid of GPS navigation and terminal optical guidance. For most of the approach, it navigates using encrypted satellite signals. But in the final 15 seconds, the most critical phase, it switches. The The system's advanced image recognition algorithms lock onto the target visually. The drone is no longer just following coordinates. It is now hunting by sight. This dual-platform approach is devastatingly effective. The Mavic provides the long-range eyes, while the FPV drones deliver the lethal sting with minimal exposure. Hitting the train, however, is a formidable challenge. It's a moving target, covering roughly 11 meters of track every single second. The calculations must be perfect. Through his video goggles, the operator sees the feed from the drone's fixed-mount camera. The world tilts as he guides the quadcopter, the crosshair steady on the lumbering fuel car. The Russian train continues on, completely oblivious. A rolling bomb counting down its final 30 seconds. Then, at 0244 hours, something changes. The operator's feed flickers. 3 kilometers away, a Russian LER-3 electronic warfare system roars to life. Mounted on a truck chassis, its antennas begin blasting powerful jamming signals across a 30-kilometer radius. The system detects the drone's control frequency and attempts to sever the link. Its goal is simple: disrupt the signal, break the pilot's control, and force the drone to helplessly fall from the sky. The drone operator reports heavy jamming. His control interface flashes with connectivity warnings. The Russian EW operators begin with a brute force approach, broadband jamming. They transmit high-powered noise across multiple frequency ranges at once, a wall of electronic static. When that doesn't work, they switch to spot jamming, focusing their intense interference on the specific 2.4 GHz band used by many commercial drone systems. But the Ukrainian operators and their machines were built for this. They had anticipated this exact scenario. The drone system employs frequency-hopping spread spectrum technology. It doesn't stay on one frequency. It changes hundreds of times per second, dancing between channels across multiple bands simultaneously. For the Russian jammers, trying to lock on is like trying to catch smoke with your bare hands. The Mavic, still circling high above, continues to provide a stable, real-time feed, its own software automatically finding clear channels. The FPV pilot announces he is switching to his secondary frequency. His system automatically hops to a backup channel, the data link spreading its signal across a new pattern. The LER-3 operators, frustrated, escalate their attack. They move beyond simple jamming and attempt GPS spoofing. They transmit false satellite signals, trying to trick the drone's navigation system into thinking it's somewhere else. But inside the drone's guidance computer, a silent guardian takes over. The inertial measurement unit, a collection of accelerometers and gyroscopes, detects the mismatch between the fake GPS data and the drone's actual physical movement. It instantly discards the corrupted signal. The drone now navigates on its own, feeling its way through the air, immune to the electronic lies. This internal navigation cannot be jammed, it cannot be spoofed. The operator reports GPS signal loss, but his drone continues its deadly trajectory. The targeting system, now fully optical, locks onto the specific structural features of the tank car. Its onboard computer, trained on thousands of images of Russian railway equipment, calculates the optimal impact point. The operator makes the final call.
Autonomous mode engaged. The drone is now on its own for the terminal phase. Russian electronic warfare has been defeated. They have done all they can, and it is not enough. At precisely 0:24:43, the first Ukrainian strike drone impacts the third fuel car. The effect is instantaneous and catastrophic. The shaped charge detonates. The tungsten penetrator shears through the 12mm steel wall. The incendiary charge ignites the diesel fuel within. The explosion rips through the tanker, vaporizing hundreds of gallons of fuel in a millisecond. A massive pressure wave erupts, rupturing the car's containment systems entirely. Through the Mavic's thermal camera, the command bunker watches a tiny spark become a supernova. The strike operator confirms direct hit on Car 3. The target is burning. The destruction now feeds itself. The train's own design, built for efficiency, becomes its fatal flaw. Ventilation systems connecting the tank cars, meant to equalize pressure, now become conduits for fire. Within 15 seconds, flames from the third car ignite the flammable vapors in the second and fourth cars. The Russian locomotive engineer slams on the emergency brakes. The train screeches to a halt. It is no longer a moving target. It is a sitting duck. At 0:25 hours, with the center of the train engulfed in a raging inferno, the follow-up strikes begin. The burning cars are now a massive beacon in the night. The second FPV operator selects his target, the sixth tank car still intact. He approaches from the southeast, using the billowing smoke as concealment. His drone's thermal optics easily lock on to the cool metal signature of the undamaged tanker. The targeting computer compensates for the heat distortion from the inferno beside it. The Mavic overhead, its AI-enhanced sensors cutting through the smoke, designates the target. The operator reports, engaging car 6. The drone dives. The shaped charge strikes with the same devastating precision. Another 69 tons of diesel fuel erupts, the new explosion merging with the existing fire. The inferno doubles in size. Simultaneously, the third operator makes his move. He targets the rear of the convoy, where the last 2 cars remain untouched. He brings his drone in from the west, a different attack vector to ensure complete destruction. He strikes the 8th and final car. The impact triggers the exact same sequence: penetration, ignition, catastrophic combustion. Another massive fireball joins the chain reaction. In the span of 90 seconds, 3 precision strikes have ignited 560 tons of fuel. The fire is now so immense, it is generating its own weather system. Intense heat creates powerful convection currents, pulling air into its base and sending a column of smoke and fire over 200 meters into the night sky. The railway line itself is annihilated. The intense heat has warped the steel tracks into twisted ribbons of metal. The wooden ties have burned away to ash. Debris from the exploded tank cars litters the right-of-way for hundreds of meters. It will take Russian repair crews weeks, if not months, to restore this critical logistics artery. And that assumes they can work without the constant terrifying threat of another strike. A vital Russian supply line has been severed. An entire week's worth of fuel for thousands of troops is gone. Achieved by a handful of skilled operators, a few courageous civilians, and 3 perfectly executed strikes. All caught in stunning 4K clarity, a testament to a new era of warfare. This is Navy Goba. Subscribe for real-time battlefield updates and strategic breakdowns.